Hello students, welcome to the new session. In this session we are going to discuss about the displacement, velocity, acceleration, numerical problems. Okay, see here we have two problems. The first one is the displacement of the particle, the displacement of simple harmonic particle x equal to 10 sine pi by 3t plus pi by 6. 10 by pi by 3 plus pi by 6. So then find the distance covered by the particle in 3 seconds. Distance covered by the particle in 3 seconds. So let's try to solve that. So here first of all what they are given. You can write the equation x equal to 10 sine pi by 3t plus pi by 6. Pi by 3t plus pi by 6. So if you are writing the expression as a sine omega t plus pi, a sine omega t plus pi. So they are asking to find how much a distance which traveled in 3 seconds. To find that, first you can try to get what is the period, what is the time period of the motion. So for that, if you are comparing that, a is equal to 10 and omega is equal to pi by 3. And phase pi is equal to pi by 6. So actually what is our requirement? Our requirement is distance traveled in 3 seconds. So to find that, first I require time period. For the time period we can able to write 2 pi by t is equal to pi by 3. Omega is equal to 2 pi by 3. Then pi value will be cancelled. Yes, so then time period t is equal to 2 3s are 6. How much? 6. What is that? 6 seconds of a time period. 6 seconds of time period. Now we need to get how much displacement which traveled in 3 seconds. In 3 seconds how much displacement or how much distance it is traveled. So see here, means what is the meaning of time period? This is the mean position, extreme position, extreme position. Time period means the time taken to travel from one extreme to next extreme. Again it has to be come to the same position. For this total time is taken 6 seconds. So now for 3 seconds, in 3 seconds how much displacement? In 3 seconds it can able to travel from extreme to extreme, extreme to extreme. So or else mean to extreme and again extreme to mean. So then the total distance traveled is equal to 2 into a. 2 into a. From here to here. See here. Half of the oscillation. Half oscillation. Not full oscillation. Only half oscillation we are taking. A. So now that is a 2a. Then distance traveled is equal to 2 into how much? 10. So that is equal to 20 centimeters. How much? 20 centimeters. And let's see the one more problem we have. What is that? The time period of simple harmonic oscillation is 8 seconds. Period of oscillation is given as 8 seconds. And what is the requirement? When the particle starts from mean position at t is equal to 0 seconds. At t is equal to 0, the particle where it is? At the mean positions. And what is their requirement? The requirement is the distance traveled by the body, the ratio of distance traveled by the body in the first second and second second of its journey. First second and second second of its journey. First second and second second. So see here, very easy and as well as interesting question. So this is we can consider like a first second. And this is we can consider like second second. So this is a mean position and this is extreme position. Mean position and extreme position. So from mean position to extreme position, first you try to get how much time is taken. How much time is taken. The time taken to travel from mean position to extreme position. From mean position to extreme position. From mean position to extreme position. How much time is taken? T is equal to T by 4 seconds. Yes or no? Yes. T by 4 seconds. T by 4. T is nothing but 8 seconds by 4. Nothing but how much you are getting? 2 seconds. Means the total time taken from mean to extreme. How much time taken? 2 seconds. We know that one thing. How much time taken to travel from 0 to a by root 2? 0 to a by root 2. How much time is taken? T by 8. How much time? T by 8. Again from a by root 2 to a, how much time taken? A by root 2 to a also T by 8. T by 8 means this is T value how much? 1. Sorry, T value how much? 8. So that is nothing but this is we can take treated like first second. Yes or no? Yes. And this is we can treat it like second means how much it is also period 1 second only, not T by 8. So for that just you can rewind the previous one. So whatever I am giving na 0 to a by root 2, how much time taken? 0 to a. If you know that is easy to solve. So then first second, how much distance which traveled? How much distance? Y1 is equal to a by root 2 to 0. 0 to a by root 2. That means displacement traveled in the first second is a by root 2. And displacement second travel in the second second is from where to where? A by root 2 to a. Nothing but a minus a by root 2. How much? A minus a by root 2. So you can take common a and take the LCM. Root 2 minus 1 by root 2. Root 2 minus 1 by root 2. Then take the ratio of y2 upon y1. Y2 upon y1. A by root 2 into root 2 minus 1 by a by root 2. A by root 2, a by root 2 cancel. So then that is equal to root 2 minus 1. What is this? Ratio of distance travelled by the body from first second to the second second. First second to the second second. And you may ask, sir, if we are not remembering this formula, so then what I have to do? Then what we have to do? So there is a one more condition is there. So for that, but little bit lengthy that is. What is that? So first you have to take from 0 to in first second which traveled y1 displacement. You can take that y1 equal to what we can able to write? A sine omega t1. A sine omega t1. T1 is nothing but 1 second. So then y1 is equal to what we are taking? A sine omega is nothing but 2 pi by t. T is equal to time period how much? 8 seconds into T1 is 1 second. Means how much you can get? Y1 is equal to A sine pi by 4. Means nothing but how much this pi by 4 is? Pi root 2. That means Y1 displacement how much you got? A by root 2. Next means next second from where it starts? From the distance of a by root 2 to which distance that is going? A. Which distance that is going? A. So take total time period is how much? 2 seconds. So then the total displacement from here to here, the total displacement I am considering as y2 dash. Total displacement A sine from here to here how much time? 2 seconds. 2t. 2t, or else you can write t1 plus or t2. First second plus second second. So if you are simplifying it, how much you are getting the value as a only, because see here a sine omega is nothing but 2 pi by 8 into 2. So into 2 means actually how much you are getting? Pi by 2. So total displacement is A. In the second only how much displacement which travel? In second only how much displacement which travel? A by root 2 to A. Nothing but A minus A by root 2. If you are taking the ratio, again you are getting that. But in competitive examination, always we have to solve the problem within less time. So that's why don't go this, better to learn that. Here two more problems are there for us. See the question number 3. What is the question number 3? The time period of oscillation is 16 seconds. Time period of oscillation is 16 seconds. And at a t is equal to 2 seconds, the particle is at mean position. Means it is the motion not starts from mean position. The motion not starts from extreme position. That's you have to remember, because you have to understand t is equal to 16. The meaning of that, time taken to travel from mean to extreme 4 seconds. Means the particle starts from middle somewhere else, right? Yes. T is equal to how much? 2 seconds. The particle is at mean position. While at a t is equal to 4 seconds, the velocity of the particle is 4 meter per second. The velocity of the particle is 4 meter per second. Where at a t is equal to 4 seconds, the velocity of the particle is 4 meter per second. And what is the amplitude? What is the amplitude of the motion? Okay, let's see. T is equal to 16, time period of oscillation. And the particle starts from somewhere else, and which is after 2 seconds, which is at mean position. After 2 seconds, it is at mean position. See here, how much time is taken to travel from extreme to mean? Yes, of course. How much time? 4 seconds. 4 seconds. In 2 seconds, how much displacement which traveled? How much displacement which traveled? 2 seconds means half of this time. How much displacement which traveled? Yes. How much? Simply a by root 2. How much? Simply a by root 2. No sir, how do we can calculate? Think. X is equal to a sine omega into t value 2 seconds. Take a sine omega 2 pi by 16 into t value how much? 2 seconds. T value how much? 2 seconds. So that means how much you are getting? Yes. Sine pi by 4. Sine pi by 4 means how much you are getting? Displacement a by root 2. Displacement how much? A by root 2. Now they are given the velocity. Velocity v is equal to omega into under root a square minus x square. Omega into under root a square minus x square. So velocity is 4 seconds. Omega value how much? 2 pi by t. T is equal to 16. 2 pi by t. T is equal to 16. And under root a square minus x value how much? A square by 2. Root 2 whole square. That becomes 2. Because our requirement is amplitude. So that's why I am taking it. Now 2 cancel. So remaining how much you have? Remaining you have here 32 is equal to pi into a by root 2. 32 is equal to pi into a by root 2. Then amplitude a is equal to 32 root 2 by pi. 32 root 2 by pi. Which option? Yes, second option. Second option. Third option, sorry. 32 root 2 pi. Third option. Let's see one more problem. Fourth problem. What is the fourth problem? A body is dropped from a height h. Body is dropped from a height h, and which is making elastic collision. Elastic collision means its energy remains constant. That means again the body is rebounds to the same height. Elastic collision means again the body rebounds to the same height. Body rebounds to the same height. Elastic collision, and it is at a height h onto the floor. Makes elastic collision. Then find the frequency of oscillation. Frequency of oscillation. Very simple question, but you have to think some logically. We are dropping from a height h, and the time taken by the body to reach the ground is we are considering as the t. T is the time taken by the body to reach the ground. Means is it a complete oscillation? No. Again which reaches the highest position. Again which reaches the highest position. जब ये highest position के जाते उसको बोलते हम complete oscillation. Complete oscillation. Right? Now what is the time period of oscillation is 2t. Time period of oscillation is 2t. Yes or no? Time of ascent is equal to time of descent. Time of descent is equal to time of ascent. So how much time is taken to reach the ground? Again same time taken to reach the same point. Same time taken to reach the same point. So that's we are taken as time of. Now let's say you try to get here displacement h is equal to what we can able to take? Half gt square. Displacement h is equal to half g t square. Then t square is equal to, we can take 2h upon g, then t is equal to under root 2h upon g. Time period t is equal to what we can able to take? Under root 2h upon g. Then time period t is equal to 2 into under root 2h upon g. Time period t is equal to 2 into under root 2h upon g. Then frequency is equal to, frequency is nothing but reciprocal of time period. The reciprocal of time period means how much you can get? 1 by 2 into under root 2h upon g. 1 by 2 into under root 2h upon g. This is the frequency of the oscillation. The frequency, sorry, 1 by 2 into g by 2h. G by 2h, sorry, it is going reverse now. 1 by 2 into under root g by 2h. So just observe how I am solving. First, whenever we are getting the problem, first we need to understand the problem and we have to identify the suitable formulas and then substitution calculation. Okay, let's see one more problem. Interesting and as well as easy problem. A particle executing simple harmonic motion in a straight line, and it has the velocity u at a point and velocity v at another point, means velocity at two different instants, u and as well as v, and the accelerations are alpha and as well as beta. Accelerations are alpha and as well as beta, and one condition is given: beta is greater than alpha. Beta is greater than alpha means acceleration at point v velocity, their acceleration is more, and alpha is greater than 0 means that is also means what is the meaning of that? You have to understand both accelerations in one side, both accelerations in one side. That is most important here to understand it. The question number 5th, see here. So what you have to understand here in the statement of beta is greater than alpha, alpha is greater than 0, the meaning of that generally what we are taking, this is a equilibrium position, mean position, and these are extreme positions. So if they are giving beta here and alpha here, at that time they are not mentioned, they may mention the situation like this. That means if it is another side, the means of that alpha value is less than 0. Alpha value is less than 0, but it is both are in the same side, so that's why alpha is greater than 0. Alpha is greater than 0. So now see the situation. What they mentioned, you can take in a straight line, means you can take both are in the same side of the mean position. Both are in the same side of the mean position. This is u velocity, and this is I am considering v velocity. At the u velocity, alpha acceleration, v velocity, beta acceleration. And you may ask the question, sir, why you are considering this is as u? Why you are not considering this is as u? Yes. So always we know that whenever the particle is nearer to the mean position, displacement less acceleration. Displacement more acceleration. Here beta is more, so that's why it is having more acceleration. And this I am considering the displacement of y1, and this is y2. This is y2. Now we need to get the distance between them, means y1, y2 minus y1. Hope you understand the problem. Once again, see here what is the problem. A particle executing simple harmonic motion in a straight line. At two instants, it is having velocities u and as well as v. At u velocity, its acceleration is alpha. At v velocity, its acceleration is beta. U velocity acceleration alpha, v velocity acceleration is beta. Now what they are asking, what is the distance between the two instants? Distance between the two instants. And also one more condition we have, beta is greater than alpha. Beta is greater than alpha. Alpha is greater than 0. That means both are in the same side. Both are in the same side from mean to extreme position. Okay. Now we try to write the equations in terms of velocity and as well as this. U is equal to omega square, or U is equal to omega into under root a square minus y1 square. What is a? Amplitude. What is omega? Angular velocity. You can take square. V square equal to omega square a square minus y1 square. Then u square equal to omega square a square minus omega square y1 square. Keep it as equation 1, velocity of the first particle. Then take velocity of the second particle, v square equal to omega square a square minus omega square y2 square. Take it as equation 2. Equation 2. For our convenience, I am taking u square minus v square. Again, why? U value numerically greater than v, because it is nearer to the mean position. Now, if we are taking this omega a square, omega square a square, both are cancelled, and remaining what you have? Omega square y2 square minus omega square y1 square. Omega square y2 square minus omega square y1 square. Then u square minus v square, omega square common, y2 square minus y1 square. Y2 square minus y1 square. Now, now what you have to do? Take the acceleration functions also. Take the acceleration functions also. What are the values of acceleration? What are the values of acceleration? Alpha 1 is equal to omega square y1. Beta is equal to omega square y2. Omega square y2. Now just add both. If you are adding alpha plus beta is equal to omega 1 plus y1 plus y2 into omega square. That means y1 plus y2 is equal to alpha plus beta by omega square. Take it as equation 2, because it is 1 from equation 1. Equation 1, what you can able to write? Y2 square minus y1 square is equal to u square minus v square upon omega square. Right? Yes. A square minus b square. A plus b into a minus b. Y2 plus y1 into y2 minus y1 is equal to u square minus v square upon omega square. Now y1 plus y2, put the value of y1 plus y2. What is the value of y1 plus y2? Alpha plus beta by omega square into y2 minus y1, which is equal to u square minus v square upon omega square. Omega square cancel. Then y2 minus y1 is equal to only y2 minus y1. How much you can get? U square minus v square upon alpha plus beta. U square minus v square upon alpha plus beta. Very interesting and as well as easy problem, and we got it a second option. Okay, let's see one more easy and interesting problem. What is that? The amplitude of the simple harmonic motion, a particle executing simple harmonic motion with an amplitude of 10 centimeters, frequency 2 Hz, at t is equal to 0. A particle is at a point where potential energy and kinetic energy are same. Where potential energy and kinetic energy are same. The equation for displacement is, we need to get equation for displacement. First, what are we have? See here, the problem number 6. What we have? Amplitude we have 10 centimeters. Means you can write 0.1 meter. Frequency we have 2 Hz. Frequency we have 2 Hz. 2 means this we can able to write frequency. Generally omega is equal to, we are writing 2 pi into frequency, 2 pi f. Then f equal to omega is equal to 2 pi f. That means omega is equal to 2 pi into f. F is 2. Then omega, how much you are getting? 4 pi. Omega, how much you are getting? 4 pi. And one more condition they are given, that at where the potential energy and kinetic energy are same, where the potential energy and kinetic energy are same. We know that, and in the last video I gave one table for you, a table at different positions, different values, right? At 0 at 0 means at mean position, maximum kinetic energy, minimum potential energy. At a by 2, kinetic energy is 3/4 of the total value and potential energy is 1/4 of the total value. At a displacement a by root 2, kinetic energy is half, kinetic energy is half and potential energy is also half. At root 3a by 2, kinetic energy is e by 4 times less, and potential energy becomes 3/4 times. Right now? Yes. From where to where? From 0 to a by root. What is the phase? Here to here, phase is pi by 6. That's why I told you have to learn the table. From here to here, pi by 4. Pi by 4 means the particle starts from where t is equal to 0, where from a by root 2 means the phase is equal to how much you have to take? Pi by 4. Is pi by 4. If it starts from mean position, then phase is 0, but it starts from extreme position, sorry, somewhere at. So now write the displacement expression, a sine omega t plus pi, a sine omega t plus pi. So then a value 10 nor 0.1 meter, sine omega value, omega how much? 4 pi t plus pi by 4, pi by 4. So this is the displacement expression. Displacement expression, first option, 0.1 meters sine 4 pi t plus pi by 4. So please practice the table properly. You can able to solve any problem from oscillation based on distance, velocity, acceleration and even in energy. So please learn the table properly.